So if anyone have any queries in between, just type in the comment section, because I won't be able to listen to what you are saying since I'm using the mic, caller mic. This is what we were discussing in the last class, and we have seen the various parts of it. And one of your friend have already given the answers, that what we call what. Once again, for your reference and for your recapitulation, I am writing it once again. So this part is known as shank. If you know the answer, you can meanwhile comment in the chat section so that your fundamentals also will be revised. So this is known as shank. Okay. And here, this face is known as end flank, na? End flank. What is this face? What is the name of this face? What is the name of this face? Side flank. Good. This is side flank. This one is end flank. The top is rake face. Okay, the top one is rake face. Just 1 minute. Okay, the top one is rake face. So where the rake face meets the side flank, we will get one edge. Where the rake face meets the side flank, we will get one edge. And where the side flank meets the rake face, we will get another edge. Where the side flank meets the rake face, we will get another edge. One is the red edge, another one is the yellow edge. One is the red edge, another one is the yellow edge. So what is the name of this red edge? And what is the name of this yellow edge? What is the name of this yellow edge? Red edge is side cutting edge. Good. And we have one yellow edge, which is known as end cutting edge. Very good. Very good. Very good, Janvi. Very good, Tejasvi. And cutting edge. Okay. Now we have also discussed one point, that where these three surfaces meet, okay, where these three surfaces meet, which is the rake face, okay, the side flank, okay, and the end flank. These three surfaces meet at a point. These three surfaces meet at a point, this point. And this point is known as either point. This is known as either point or nose. Very good, Nihatri. This is either known as point or nose. Now you tell me one thing. I would like to ask you, or I will just draw one diagram and then I will ask you. So here I am giving these edges some names or some numbering with black ink. Let us suppose this nose is 0, okay, and the ending of the side cutting edge is 1, and the end of the end cutting edge is 2. So I have given it naming 0, 1. If I say 0, 1, you should understand that I am talking about side cutting edge. If I say 0, 2, you should understand that I am talking about the end cutting edge. So actually I will draw the diagram. This is a textbook diagram, okay? But now I will draw a diagram which will show that how this tool is kept when you are doing the turning operation. Okay. For that, I need to go to different software. So this is another software, OneNote. In this, we can draw any type of geometries very easily. Okay, so I will try to draw that. I will try to draw. Yes, which color should I choose? Dark green. Okay. So basically, what it is our workpiece. Okay. And now I'm drawing the tool. All of you see carefully how I am drawing the tool. In the exams, you have to draw the tool in the same manner. Okay. So do you agree with me that I am showing the backside view of the same diagram, which is this one. I'm showing you the backside view of the same diagram in this one. Do you agree with me or not?
Yes, sir.
Do you agree with me or not? So, actually, I can't listen. I don't remember your name. Just a minute. Yes, Nayak. So please comment in the chat section. Okay. Now you tell me that which edge should I give here. Here I have already given the names. You have seen that I have given the name 01 and 02. Na? So here you tell me which edge should I give the name 01 and 02. So here this is 0, this one is 0, this one is 1, and this one is 2. Okay, 0, 1, and 2. So basically what I mean to say is, only the side cutting edge is coming in contact with the workpiece and it is contributing in the machining operation. This is the end cutting edge. This is the end cutting edge. This is the end cutting edge, and it is not at all coming in contact with the workpiece. It is not at all coming in contact with the workpiece. With this diagram, we can easily see that we have got two cutting edges. This 01 is the side cutting edge. This 02 is the end cutting edge. But with the workpiece, only this side cutting edge, some part of this side cutting edge, up to this point, only the side cutting edge is coming in contact. This 0 point is obviously coming in contact, but apart from that, only the 01 part up to this green highlighted part only is coming in contact with the workpiece. Then why should we call this 02 as one of the cutting edge when it is not at all contributing in any of the cutting, or when it is not at all coming in contact with the workpiece? Why should I call it? Tell me, anyone? Why should it be called like that? Anyone having any guesses or anything? Why should it be called like that? Tell me, diploma students, you have already studied this subject. Repeat the question once again. Okay, Hemant, you see this diagram? You see here, Hemant? You see this 0, 1 and 0, 2? 0, 1 and 0, 2, you see? 0, 1 is side cutting edge, 0, 2 is end cutting edge. Okay. The same diagram I will show you here. The same diagram I will show you here because someone have given the answer. Just a minute, I'm repeating the question. The same diagram I'm showing you here. Here 0, 1 means this one is end cutting edge, 0, 2 means side cutting edge. No, sorry, 0, 1 means side cutting edge, 0, 2 means end cutting edge. Okay, the same diagram. So here 0, 1 is side cutting edge. So only this side cutting edge is getting in contact with the workpiece. Okay. This 0, 2, which is the end cutting edge, is not at all making any contact with the workpiece. Only up to this point there is a contact, right? No, Tejasvi. No, not like that. Okay. So why do we call then, as per Tejasvi, what she is saying, that if you are cutting from the another side, then 0, 2 will come into play. Then why do we call this 0, 2 as minor cutting edge or auxiliary cutting edge? Then this should be also a principal cutting edge, na? Then why we are giving it name as minor cutting edge or auxiliary cutting edge? We have given it some names. This 0, 1 is known as principal cutting edge, major cutting edge, main cutting edge. This is 0, 2 is known as secondary cutting edge, like that. So if, as per Tejasvi's answer, what she is saying, that when you are doing machining in this direction, then this will come in contact with the workpiece. But that is not the case. In that case, this 0, 2 should also be called as a principal cutting edge only. How many of you have understood the question? And if you have already, it is used to avoid rubbing. Okay, your answer is somewhat correct, but you tell me why 0, 2 is known as cutting edge. If it is used to avoid rubbing, I should have called it by some other name. Someone have given the answer actually. Someone have wrote something. Nose or point. Because we can use it as cutting edge other angle. Okay. You also said the same thing. Okay. For that purpose, we need to understand a concept. We need to understand a concept which is known as nose radius. For that purpose, we need to understand a concept which is known as nose radius. Okay. All of you listen carefully. What is nose radius? How many of you have traveled in aeroplane? Say yes, comment in the chat box quickly. How many of you have traveled in aeroplane, flight? How many of you have traveled in aeroplanes? Say yes. Hemant Naik have traveled. Verma has traveled. Yes. Okay. And Nitla is also traveled. Okay, Niharti. She has also traveled in airplane. So if you have traveled in an airplane, and if I draw an aeroplane, I'm not so good at drawing an aeroplane. Just like this, if I draw an airplane, this is the rudder. Okay. Okay, this is something an aeroplane. This is something an aeroplane. This is one of the wing. Our concentration is on the windows. How the windows of the airplane are, whether they are like this, or whether they are like this. How they are? How windows of aeroplane are? Blue color or oval shape, na? Why? If you give me the answer oval shape, then you tell me why. Oval. Yes, obviously it is oval shaped, or we can say it is little bit of elliptical shaped, oval shaped. It is not a rectangular shaped. And most of you have traveled in aeroplane, you have already admitted that you have traveled. Now you should give me the answer that why they are oval shaped. Why they are. Very good, Santoshi. Santoshi, you attended my FT class, I guess. है ना? Because I told all these things in my FT class. Yes, yes. Okay. That's why you gave the answer. Good. So that's why they are oval shaped. Santoshi have given the answer because she studied FT with me. So all these stories I generally used to tell in the class. So you see, whenever you have sharp corners, due to edges, there will be resistance if it's rectangular or square. Due to edges, what kind of resistance? Resistance to the flow in air. Listen carefully, what am I telling? This is not any story. This is something which is related to subject. Okay, don't think that I'm passing time by telling you stories. So whenever you have sharp corners like this, here one is sharp corner, here one sharp corner, here one sharp corner, here one sharp corner. So there are four sharp corners are there. So whenever there are certain sharp corners in any component which is subjected to any stress, so actually aeroplane is subjected to stress from inside because it is flowing in the air where the pressure is less, and inside pressure is more. Inside pressure is more and outside pressure is less. So that's why it is like a balloon. Aeroplane is like a balloon. So obviously the windows are subjected to some amount of stress from inside. Okay, the walls are subjected to some amount of tensile stress. So whenever you have sharp corners, okay, so pressure is equals to what? Force upon area. Pressure is equals to what? Force upon area. So at these sharp corners, at this particular point, what do we have? We have area very less area. Okay, the force is constant. But the area is changing. Okay, since we are having sharp corners, the area is very, very less. So when denominator is less and numerator is constant, but the denominator is less, the fraction will become increased or decreased. When the numerator is less, when the denominator is less and the numerator is okay, constant, it is not changing, but the denominator is reduced, the fraction will increase or decrease? The fraction will increase. So what happens is at this particular point, the stress will be very, very high. Pressure is equal to force upon area. Stress is also equals to force upon area. Na? Stress is also equals to force, load upon area. So what I can say is, at these corners, if the corners were made like this, at these corners, the stress will be very, very high. And the stress might go to such a level that it might go beyond the fracture strength of, or the ultimate strength of the material, and the material will start to crack from this location. Now, material will start to crack from this location. Okay, so that's why aeroplane windows are made oval shaped like this, so that area is same at each and every corner. There is no sharp edges where the stress concentration is at the higher end. So that's why they are made oval shaped. Okay, you see submarines and all. In submarine and all, the windows are circular in shape. They're circular. They also avoid sharp corners. Getting my point? Or not? If you see old aircrafts, when aircrafts were very, very new, at that time we used to have such kind of sharp cornered windows. So many flight crashes have taken place in the past, which were due to the stress concentration and the internal cracks that have built up, and midway aircraft have blasted like anything, because there is a small crack. The crack propagated, and there come a time when the crack becomes so dangerous that it will give rise to a big blast in the body of the aircraft. Why? Because air is at a higher pressure from inside, air it has a lower pressure from outside, so aeroplane will act like a balloon. So why I am telling you all this story? Have you understood the story? First tell me, have you understood the stress concentration factor? Why stress is higher at sharp corners? Because the area is less. The load is constant, the force is constant, but the area is less. But since the area is less, automatically the stress will increase, right? Now let us come back to our subject. Here you see This is what? Where three surfaces are meeting, this this surface, top surface, nose. Okay. Side flank and end flank, where these three are meeting, we are getting a nose or a point. You tell me, when we have three surfaces meeting at a point, that point will be a sharp point or not? That point, green point, is sharp or not? How it will, how it will be? It will be sharp or not? Tell me. Definitely it will be sharp. 100% it will be sharp. 100% it will be sharp. So when it is sharp, then what happens is, when you do the machining operation, since the point is very, very sharp, or I would rather say, since it is very, very sharp, its area is very, very less. So very, very high amount of stresses are built up at that point O. Very, very high amount of stresses will be built up in that point O, because it is very sharp. And we are applying some load, we are feeding the tool in this direction, we are giving depth of cut in this direction, and we are feeding the tool in this direction. So obviously some forces are acting on the cutting edges. Since this 0, 1 is having greater area, so the forces will be distributed. But since this point O is very sharp point, very, very sharp point, a very, very huge amount of stresses will be developed in the point. And after some time in the machining, what will happen? This tool will get failed from here. The tool will get failed from here. Why it will get failed from here? Due to stress concentration. So this is the problem. Now I am asking you for a remedy. That this is the problem that we are facing. Being an engineer, what would you suggest? What should we do in order to protect the nose, or in order to protect the point? What should we do? Quickly tell, yeah. You already know the remedy, na? What you have to do? Diploma students can easily give the answer, but they are not giving the answer because they already know what I'm trying to round it. Okay, good, very good. Anyone else? 40 students are there in the class. 20 of them are sleeping, 20 of them are listening. So what do we do is, instead of keeping the nose sharp, instead of making the nose sharp, we generally give a small radius to the nose. And that radius is known as nose radius. Okay, that radius is nose radius. So this nose is never made sharp. Why? Because if the nose is made sharp, then due to the forces of cutting, since the area of the nose will be very, very less, huge amount of forces will be developed, huge amount of stresses will be developed in the nose, and that might give rise to the premature breakage or premature damage of the cutting tool. Okay, since the nose is sharp. So in order to protect the nose, yes, it will happen, Ganapati, because we will not give very high radii. We won't give very, very big radius. We give very small radius. Okay, it is very, very small radius, and I will also tell the range of the radius. It is not a big radius, it is very, very small radius. The radius is given in order to increase the area. You don't think that we are giving 15 mm radius or 20 mm radius, not like that. We will give very, very small values of radii in order to protect the nose. Now you come back to my previous question. I asked you that 0, 2, which is the auxiliary cutting edge or the end cutting edge, it is not at all contributing in the machining operation. It is not at all making any contact with the workpiece, but still it is known as one of the cutting edge. So why it is known as one of the cutting edge means, when you give radius to the nose, very small part of this 0, 2 will also come in contact with the workpiece. Say yes or no. When you give slight nose radius to the point, a very, very small portion of 0, 2 will also come in contact with the workpiece. That's why this 0, 2 is known as secondary cutting edge or auxiliary cutting edge or minor cutting edge. But this 0, 1 will definitely be the main cutting edge or principal cutting edge or the major cutting edge. Now you understood the concept. Now you understood the concept that why 0, 2 is known as minor cutting edge. It is not like that when you do the machining operation in the reverse direction, this 0, 2 will become the major cutting edge. No, we will never do the machining in the reverse direction because this tool is supposed to be operated only in one direction. You can't do the cutting operation in the reverse direction. If you do that, then your surface finish will be completely deteriorated. You will get a workpiece which should be thrown into trash. You can't use it. Surface finish will be very, very bad. Okay. So I hope that you have understood this. Okay. So now I will explain you, or I will write the statement control plus alt plus M, control plus shift plus M. Yes. I'm writing here the tip of the tool is never made sharp as sharp corner is never made as sharp corner. It is always given certain radius. It is always given certain radius called as what? Nose radius. Called nose radius. So that the stress is propagated, so that the stress is propagated and premature failure of tool, or I would say premature failure of tip of the tool, does not take place or can be avoided. Can be avoided. Okay. So this is known as, this is the concept of nose radius. Concept of nose radius. Concept of nose radius. Okay. Now let's come back in this diagram. This red part is what? Tell me. This red part is what? And this green part is what? First you tell me the red. Hey, rake face. How it is rake face, red part? Hemant Nayak, you see, I have shown it with dotted lines. I have shown it with dotted lines. When I'm showing it with dotted lines, it means that this is the cutting edge and the surface which is below the cutting edge. Side flank is red. Right, right. Side cutting, not side cutting. It is side flank. This is side flank. What about this green one? What about this green one? This green. Green is end flank. Very good. This is end flank. And this one is side flank. This one is side flank. Now, I will ask you one more thing. You tell me which color should I use? Yeah, this one. Now, what is this color? What is this one? What is this one? Tell me quickly. Maroon color. Maroon color surface is which surface? Rake face. This is rake face. Rake face. Rake face. Very good. All of you are getting the points. All of you are getting the subject. That's important. Not take face. Tejasvi, not take face, rake face. So when you are doing the machining operation, when you are doing the machining operation, spelling, no, you have written take face, so I will consider that only. You should make sure that you should not commit any spelling mistakes. So when you are doing the machining operation, chips are produced like this. Chips are produced like this. Chips are produced like this. Okay. Right? Chips are produced like this. The chip should go in this direction. Chip flow direction. Okay. Now, what will happen if the chip, instead of flowing in this direction, if the chip flow in this direction? If the chip flow in this direction, then what happens? This direction means if it is flowing towards the machined surface. So basically, one thing I forgot to tell, that this surface is known as machined surface. This surface is known as machined surface. Now, what do we call this surface? One surface is machined surface. Another surface is what? Tell me what should be its name. Quickly tell yaar, don't waste time. Unmachined surface. Okay. Anyone else? Unmachined surface. See, what I mean to say is, I already told you in the starting of the lecture that this is secondary manufacturing process that we are studying. Okay. So it is not like this component we have got from some ocean, or we have got from digging. This is also manufactured only. This is also machined only. Right? Means this we might have got from forging, we might have got from casting, we might have got from some other processes. So this is also a manufactured product only. The only manufactured product we are little bit modifying, or we are machining it. So that's why you never call it unmachined surface. This is known as atmospheric surface. Atmospheric surface. One is machined surface, another one is atmospheric surface. Just remember it. Okay, never say unmachined surface. So now let us assume that if the chips, instead of flowing towards the instead of flowing away from the machined surface, if they are flowing towards the machined surface, then what will happen? Tell me what will happen. Quickly. See, obviously it is understood that if the chips are flowing into the machined surface, then what will happen? That these flowing chips might damage. Yeah, it will stick because they are very high temperature, so they will stick to the machined surface. And since they are very rough, the chips are very, very rough. They are like saw. So they will damage the surface quality of the machined surface. So for efficient machining, my first point is that the chips should flow away from machining zone. It should flow away from machining zone. Okay. Now my second point. My second point is here. Here I have rubbed it. You can't see. Here there was our side flank, na? And here there was our end flank. The side flank and the end flank should make contact with the workpiece or not? Tell me. The side flank and the end flank should make contact with the workpiece or not? I am not saying about edge. Listen to the question carefully. 0, 1 is the edge. See, this is the edge. This is the edge. This is the flank. Okay. This is the edge and this is the flank. So what am I asking you is the side flank and the end flank should make contact with the workpiece or not? Think and tell. For cutting to happen, the side flank, is it necessary for the side flank and the end flank to make contact with the workpiece, or it's only necessary, or it's okay that only the point and the principal cutting edge, then some part of the minor cutting edge, if it make contact with the workpiece, then the cutting will take place? Think and tell. Tell me. Quickly tell me. End flank must not be in contact. Okay. End flank must not be in contact. Good. What about side flank? The side flank should also not be in contact, because the side flank is not any sharp surface. No? It is just a pale surface. So if it is made to have a contact with the workpiece, then what will happen? Rubbing will increase or friction will increase. Rubbing will increase, friction will increase, and when the rubbing will increase, when the friction will increase, then the two things will happen. One is the temperature of the tool will increase. Temperature of tool will increase. And the second thing is that when the temperature of the tool will increase, that is the first thing. Due to that increase in temperature, tool will fail. Tool will fail. And since the friction have increased, more power is required. More power is required. Obviously, motor has to draw more current in order to rotate the workpiece, because the tool is exhibiting appreciable amount of friction on the workpiece. So for that reason, more amount of power is required, right? So we have got these three disadvantages if the flank is made contact with the workpiece. And one more thing we have already seen in the another slide, that for efficient machining, the chips should flow away from the machining zone. And the second is none of the flank should be making any contact with workpiece. Okay, none of the flank should be made any contact with the workpiece. So for this purpose, for these 2 points to be accomplished, for getting these 2 points of efficient machining, which is the chip should flow away from the machining zone, and the side flank and the end flank should not make contact with the workpiece. For this purpose, we give angles to each and every surface. Understood? In order to accomplish these 2 tasks, that the chip should flow away from the machining zone and none of the flank should be making any contact, any rubbing action with the workpiece. For that purpose, what we are doing is we will be giving slopes to the surfaces. The surfaces are not plain or flat surfaces. In order to achieve these 2 points, in order to achieve these 2 goals, we will be giving some angles. We will be giving some angles to the surfaces. Okay, we will be giving some angles to the surfaces. Now I will switch on my camera and I will tell you one concept. You just say yes or no in the chat section. Am I visible? Am I visible? For example, this is one surface. Okay, can you see it? This is one surface. Now I want to give slope to this surface. This is one slope. Okay. Now another slope I can give like this, or another slope I can give like this towards you. Okay. See, this is straight, horizontal. I have given one slope. This is another slope. Okay. Second slope, or I can give a slope towards my direction. Okay. Okay or not okay? Can I give 3 slopes? This is one slope. This is second slope. Can I give any third slope? Can I give any third slope? Tell me, can I give any third slope? Don't go for textbook definitions or anything. Just listen and ask yourself that there is a surface. Think that this is a rake surface. This is a rake surface. I have given a backward slope and I have given a sideward slope. I have given a backward slope. I have given a sideward slope. Can I give any other slope other than these two slopes? Means after giving the backward slope and after giving the sideward slope, can I give any third slope? If I give the third slope, what will happen? This surface will no longer remain a 2D surface. It will either become, it will definitely become a 3D surface if I give the third slope. This is the first slope, this is the second slope, and if I want to give slope in this direction also, then what will happen? Then it will become like this. Concavity or convexity will take place. Concavity or convexity will take place. So what I mean to say is, we can give only a maximum of two slopes to a surface. Okay, either like this or like this, either like this or like this. So we can maximum give two slopes to a surface. If we try to give three slopes to a surface, then that surface will become a three-dimensional surface. That surface will no longer remain a two-dimensional. It will become three-dimensional. Okay, so that is the reason that we can only give two slopes to each and every surface. We can only give two two slopes to each and every surface. So how many surfaces do we have? How many surfaces do we have? How many surfaces do we have? Tell me quickly. How many surfaces do we have? We have a rake surface, we have end flank, we have side flank. So to the rake surface, you give two slopes. To the end flank, you give two slopes. To the side flank, you give two slopes. So 2, 3 just 6. So total angles will be 6 angles. Okay, those who have gone for gate coaching, those who have already studied this in their diploma, they know of different angles that we have in our single point cutting tool, right? Back rake angle, side rake angle, end relief angle, side relief angle, everything you know. But why we have only those 6 angles? But why only 6? Why not 7 angles? Why not 8 angles? Because we have given only two slopes, or we can give only two slopes to each surface. If we try to give three slopes, then concavity or convexity of surface will take place, and that surface will become very difficult to manufacture. So that's why we give two angles per surface, and we end up having 6 angles. Okay, we end up having 6 angles. So we need to read about these 6 angles now. Up to this point, everything is clear or not clear? Up to this point. Up to this point, everything is clear? Yes. Those who studied diploma students, do you feel any difference? Do you feel any difference in the subject that you have studied in diploma and that you are studying in your BTech? Do you feel any appreciable difference? Many concepts are getting clear. Manikanta, many concepts which were not so clear in diploma are getting cleared here, right? Okay. 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 So today actually I am taking 2 hours class. So you want break or you want me to leave you early? You have two options. Either you want break, I will give you break for 10 minutes, or if you want, sir, continue and leave us 10 minutes early. Means instead of leaving you at 11:50, 10:50, I will leave you at 10:40. Which option would you choose? You have two options. Leave us early, na? I will continue now, and 10:40 I will leave. I will leave you by 10:40. That would be better. Okay, good. Saurabh Day, Saurabh Day, your day means you're Bengali. Saurabh Day. Day is a Bengali surname, na? Yes. Okay. So Hemant Nayak, for what you are saying, yes. He is Bengali. Oh, he is your friend, na? Yes. Okay. Shift plus control plus. So I'm writing one more point here. Just when these 6 angles and the nose radius are written in a predefined sequence, okay, in a predefined sequence, then it is known as then it is known as tool signature. Then it is known as tool signature. Okay, then it is known as tool signature. Example of tool signature I'm writing here. For example, I will rub this example actually. Okay, if you have written 7 degree, 6 degree, 8 degree, 4 degree, 11 degree, 25 degree, and 2. This should be also degree. See, already 6 angles are completed. Na? 6 angles are already completed. The last one should be what? The last one should be what? The last one should be nose radius. So radius is given in inch or mm. Good. That is mm. Okay, that is mm. 2 mm is the nose radius. So now what are all the angles? The first angle is the first angle, the second angle, this is the third angle, this is the fourth angle, this is the fifth angle, this is the sixth angle, and finally this is the nose radius. This is the nose radius, which is in mm. Yes. Tell me what is the first angle? First angle is, those who know, they should comment. The one who doesn't know, they should observe, and I will tell you best way to remember these angles. Back rake angle. The next one is side rake angle. The third one is end relief angle. Okay, the next one is side relief angle. The next one is end cutting angle. The last one is side cutting angle. Okay, we represent them as alpha B for back rake angle, alpha S for side rake angle, which means that rake angle we represent by alpha, gamma E for end relief angle, and gamma S for side relief angle, psi E for end cutting edge angle, and psi S for side cutting edge angle. Okay, alpha B, alpha S, gamma E, gamma S, psi E, psi S plus nose radius at the end will give me the tool signature. Okay, this is an example of a tool signature. Basically, this is an example of tool signature. An example of tool signature. Now the point is how to remember this tool signature. The point is how to remember this tool signature. You only need to remember one line. Okay, the one line is BS 2 times of ES and 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 if you remember this one line because this is very important in the exam they ask you write down the tool signature in ASA system. What is that ASA system? I will explain. So they will ask you what is the tool signature. So if you don't remember this predefined order, if you just interchange this 8-degree 4 means end side and if you interchange then your answer will be wrong. For that purpose you remember this BS 2 times of ESN. Okay, BS 2 times of ESN. So if you remember this, the first one is what? Back rake angle. The second one is what? Side rake angle. 2 times of ES. So first ES is end relief angle. The second ES is what? Side relief angle. We got one more ES because this is 2 ES. So one more ES is what? End cutting edge angle. Side cutting edge angle. And finally the nose radius. I will write it once again. I asked you to remember. What did I ask you to remember? Tell me. Comment in the chat section if you remember. What did I ask you to remember? One line I asked you to remember. BS 2 times of ESN. BS 2 ESN. Good. BS 2 ESN. If you remember it, you can write it as BS ES ESN. So first one is back rake angle. Second one is side rake angle. Then end relief angle. Side relief angle. And cutting edge angle. Side cutting edge angle. And finally nose radius, which is in mm. What is this angle? Alpha B. This is alpha S, gamma E, gamma S, psi E, psi S. So this is tool signature. Okay. Next. ASA tool signature. ASA tool signature. So this ASA tool signature, what is the full form of A? Can anyone tell me? American Standard Association. ASA stands for American Standard Association. So this tool signature is developed by American Standard Association engineers. Okay. And this tool signature system is based upon the machine reference system. This is based upon machine reference system. You might find few things complicated, tricky, or unable to understand at this point, but within 15 minutes, 15 minutes, you will understand everything crystal clear. Okay, and you can teach your juniors also that what is this ASA tool signature system. Okay, So it is based upon machine reference system. Whatever tool signature that we have written here, whatever tool signature that we have written here, which follows the order BS 2 times of ESN, this is basically written in ASA form only. This is ASA tool signature only. This is ASA tool signature only. This is ASA tool signature only. Okay. But how this tool signature came, that we will understand with the help of a diagram. And this ASA tool signature is based upon the machine reference system. Okay. Now, what is this machine reference system? I will draw a diagram. All of you observe carefully. So this is a machine, and on this machine I have kept a workpiece. This is known as the headstock. This is the headstock. This is the tailstock. What is headstock? What is tailstock? We will understand when we will discuss about the lathe machine. Especially when your lab videos are out, you will definitely understand that what do you mean by headstock, what do you mean by tailstock. Okay, so don't worry. Okay, so I have kept a workpiece on a table. Is it opposite, sir? It is opposite, sir. Headstock, tailstock. It is opposite. Means this is the spindle, na? Here it is spindle. So where it is spindle, that is headstock. No, no, don't think like left side is headstock, right side is tailstock. It depends upon in which direction your machine is kept. If your machine is kept in reverse direction means if it is kept in other side of the room, then the headstock and the tailstock will change. There is no rule that headstock should be on the left side or tailstock should be on the right side. Just think that here you have the spindle. Where you have the spindle, where you have the motor, that is the headstock. And where you don't have the spindle and where you don't have the motor, that is tailstock. That's it. Maybe in your college, your machine might have kept in the reverse direction. So that's why the headstock and tailstock is changing. Okay. So now I am drawing the tool. So this is our tool. So in this tool, we have two dimensions. Okay. One is this dimension, and another one is this dimension. So what is the first dimension? Can I call it as length? Can I call it as width? Okay. And the table on which the tool is kept or the workpiece is kept, I'm calling it as the table of the machine. Okay. I'm calling it as table of the machine. So this is what? Axis of machine, because this is the axis between the headstock and tailstock. This is the axis between the headstock and tailstock. So there is a line which is passing through the headstock and tailstock. The axis is the line which is passing through the headstock of tailstock. So basically what I can say is this is the axis of the machine. Machine means machine tool. We have got a lathe machine, and this red line is the axis of that lathe machine. Okay. So this direction is known as the longitudinal direction. Okay, this direction is known as the longitudinal direction. This direction. Okay, this direction is known as the longitudinal direction, and this direction is known as the transverse direction. This direction is known as the transverse direction. So what I am doing is this plane, I am thinking it as a plane. This is known as pi x plane, which is the plane along the longitudinal direction. Okay. And this plane is pi y plane, which is along the transverse direction. Okay. And this is the plane, I'm calling it as pi r plane. Okay. This horizontal plane is pi r plane. One of the vertical plane, I'm calling it as longitudinal plane, and this one I'm calling it as transverse plane. Longitudinal plane, transverse plane, and this one is known as reference plane. This one is known as reference plane. Is it clear up to this point? Is it clear up to this point? I haven't did anything which is so difficult to understand. I have just taken three planes. I have considered a machine tool in which some turning operation is taking place. There is a workpiece, there is a tool, and we are assuming that there are three planes. Along the length of the workpiece, if there is one plane which is known as the longitudinal plane, along perpendicular to it is the transverse plane, and one plane which is perpendicular to both longitudinal and transverse plane is the reference plane. Okay. Now I will ask some of you one question. For example, if I have a line like this, what is its angle? Tell me, what is its angle? Comment in the chat section and tell me what is the angle of that line. Tejasvi is saying 180 degrees. We will need a reference, sir. With respect to which plane, sir? Okay. So Janvi, Hemant Naik, and other one student also. So you understood the basic concept of angles, that whenever you have given a line with respect, so with respect to which line you are measuring that angle, that decides that what is that angle. For example, with respect to this line, if I measure the angle will be something different. With respect to this line, if I measure the angle will be something different. With respect to this line, if I measure the angle will be something different. And with respect to this line, if I measure the angle will be something different. So the angle here will be this much, that is theta 1. Here the angle will be theta 2. Here the angle will be theta 3. And here the angle will be theta 4. So whenever you are given a line, you should never straight away comment that that is the angle, because with respect to which line you are measuring the angle, that makes the entire difference. That makes the entire difference. So here I have already said one definition that we have 6 different angles in a tool. Okay, 2 angles per one side. So in a total we have 6 different angles in a tool. So I have also said that in ASA tool reference system or in ASA tool signature system, that tool signature system is known as a machine reference system. The tool signature is known as machine reference system. The tool signature is known as machine reference system. Machine reference system. Machine reference system. Why it is known as machine reference system? Because here we are measuring the angles with respect to the planes of the machine. With respect to the planes of the machine. So which are the planes of the machine? This pi x is one of the plane of the machine. This pi y is one of the plane of the machine, and this pi r is one of the plane of the machine. Okay. We are, with respect to some plane, we will measuring the angle. With respect to some reference, we will measuring the angle. So here we are taking the reference as the planes of the machine. Okay, this longitudinal plane, this transverse plane, and this reference plane. So that's why this ASA tool signature is known as the machine reference system. Okay, clear? Clear or not clear? Clear or not clear? And one more thing, that we have taken reference here, different lines, and we have taken the angle. So whenever you represent an angle, you need 2 entities. One entity is that with respect to which line you are measuring the angle, and in which plane you are measuring the angle. Okay, in which plane you are measuring the angle. So most of you have told me that you are these are the reference planes. This could be the different reference lines about which you are measuring this angle. On which plane you are viewing this angle? My next question is, on which plane you are viewing this angle? On which plane you are viewing this angle? These are the lines about which you are measuring the angle. In which plane you are viewing the angle? Tell me. In which plane you are viewing the angle? You are viewing the angle in the plane of the screen. No, Santoshi. Perpendicular plane, not perpendicular plane. You are viewing the angle in the plane of the screen. You are viewing the angle in the plane of the screen. On your screen, you are viewing the angle. If you are not getting it now, you will get it later. Don't worry. But one thing, 2 things you keep in your mind, that whenever we represent an angle, we require 2 things. One, about which reference we are measuring that angle, and in which plane we are measuring that angle. Okay, these 2 things you have to remember. That's why I have taken this much of time in explaining you that concept, because when we will discuss in detail the ASA tool signature, you may not face any difficulty. Okay. So basically what I meant to say is, here I will keep the axis. If I keep an axis in this direction, and if I keep an axis perpendicular direction, and if I keep an axis in that direction, so can I call it as X, and can I call it as Y, and can I call it as Z? So this X is nothing but it is the longitudinal direction. This is the transverse direction, and it is perpendicular to both. Can I do like that? Can I do like that? Can I do like that? Say yes or no. See, this x is parallel to this longitudinal plane. This is the longitudinal plane, na? So this x is parallel to this longitudinal plane. This y is parallel to this transverse plane. Don't talk about z now. So to these two planes, these two axes are parallel. Okay. So can I draw it like this or not? Say yes or no. Are you not following? Are you not following? Yes, na? Okay. So let us first write the definition of longitudinal plane. Longitudinal plane. So this longitudinal plane, you observe carefully. This longitudinal plane, observe carefully. It is perpendicular to the length or it is perpendicular to the width? Tell me. It is perpendicular to the length and it is perpendicular to the width. Longitudinal plane. This longitudinal plane is perpendicular to the length of the tool or it is perpendicular to the width of the tool? Okay, very good. So this longitudinal plane is perpendicular to the length as well as base of the tool. Okay, this longitudinal plane is perpendicular to the length and base of the tool and parallel to width of the tool. Is it okay if I write like this? Anyone having any doubt? Just observe once. See, this is the length, this is the longitudinal plane. So if you keep this plane here, you see that it is perpendicular to the length. This is the base of the tool. This is the base, na? This is the base. So this is the base. So base also it is perpendicular, longitudinal plane, right? Similarly, you tell me how can I write about transverse plane? How I can write about the transverse plane? Tell me quickly. Tell me how I can write about the transverse plane. Transverse plane is perpendicular to what? Parallel to what? Transverse plane is perpendicular to what? Parallel to what? Quickly. Parallel to length. Very good. It is parallel to length and perpendicular to width and base of the tool, right? Width and base of the tool and perpendicular to the width and base of the tool. And lastly, the reference plane. Axis of the mission. Axis of the mission. What are you saying? Axis of the mission? Just a minute. Gunapati, what is axis of the mission? You mean to say by axis of the mission? What do you mean? Perpendicular to it. Perpendicular to the axis of the mission. No, you're talking about reference plane or you were talking about transverse plane? You don't give me the reference with respect to axis of the mission. You tell me with respect to length and width. That's it. With respect to length and width, I have written it is perpendicular to the width. This is perpendicular to the width and as well as it is perpendicular to the base of the tool. Finally, the reference plane. Tell me how can I write the reference plane? How I can write the reference plane? You will get to know why I am telling you all these things. Okay. You just tell me how I can write the reference plane. How I can write the reference plane. How is base perpendicular to transverse axis? This is the base, na Tejasvi? This is the base of the tool. This is the base of the tool. This is the base of the tool. So this transverse plane is not perpendicular to this base. If I keep the tool here and this is the base of the tool, so the angle between these two is what? 90 degrees or not? Got it? Perpendicular to both length and width. Which one? Which one is perpendicular to both length and width? Reference plane. Okay. Reference plane is what? Tell me. Reference plane is parallel to the base of the tool and perpendicular to both length and width of the tool. Good. This is parallel to base of the tool and perpendicular to what? Perpendicular to what? Parallel to the base of the tool and perpendicular to the length and width. We have already given the answer, I guess. Parallel to base and perpendicular to length and width. Okay. Parallel to base and perpendicular to length and width. So only we will write parallel to base. Okay. No need of mentioning that perpendicular to the length and width of the tool. Alright. Okay. Only up to this point we will write. So up to this point, anyone having any doubt? See, I'm trying to teach in little depth. Is it okay? Or you just want me to, teach up to the syllabus and leave? Because if I'm trying to go to some depth, are you facing difficulties in understanding? Let me know. Be frank. For example, if this topic we are not an issue, na? This is better. Continue. Okay. No. Because what happens is when we try to get into little bit of depth, students generally start feeling boring. That's why I'm asking you, if you're not liking the subject, then I have my own other ways to make subject interesting. But the thing is that very, very important concepts you might lose. So what we will do is, up to this point we have covered up to here. We will stop here, and in Monday's class we will continue from here, because the time, I don't have much time. In 5 minutes I can't complete it. So up to this point, I hope if you have any doubts, you can ask me. Up to this point, if you have any doubts, you can ask me straight away, and we will continue from here in the next class. We will continue from here and we will see how all the angles we are getting. What we are doing is how all the angles we are getting. In the next class, quickly I will once again recap these things of machine plane and all, and we will continue from Monday's class. Right? Or can I continue? If you want me to continue, I can continue up to 11. Shall I continue? No? Why? Okay. So we'll stop here. Tejasvi, why are you saying no? You should not say like that. Always remember this, huh? BS 2 times of ESN. Anyone have any doubt? Anyone have any doubt? Battery is low, then connect the charger. Battery is low. What will you do if battery is low? Connect the charger. You can't ask your teacher to stop the class, na, Tejasvi, just because your battery is low. I will take the attendance. Just wait. Anyone have any doubt anywhere? Yes, that's why you are saying. Or else you will connect the charger, na? Anyone have any doubt?
Sir, sir,
Anyone having any doubt? No? Okay. So I will take the attendance and you can leave. 50 students are present. 51 are present. Just a minute. Okay. Thank you very much. You can leave.